Hello and welcome, electrical engineers. This is JP. Today we are diving into one of the most important topics in power system engineering, which is short circuit analysis. Short circuit calculations are essential for ensuring the safety, reliability, and proper design of electrical system. They help us determine the maximum fault current that can flow through a network during abnormal conditions. And this guide us in selecting the correct circuit breakers, protective relays, and busbar ratings. In this session, we will explore the fundamentals, the method of calculation, and why short circuit analysis is cornerstone of power system engineering. I have searched through the YouTube and couldn't be find of a proper manual calculation method for fault analysis. That's why I decided to present an easy method of fault analysis, the Fault MVA method. Even though in the real world we have powerful software tools to calculate fault level. As electrical engineers, it is important we also know how to perform these calculations manually. This knowledge is especially useful during site testing where we need to be verify breaker and relay settings. So in this session, I will explain step by step how to calculate fault values manually with an example. Stay tuned. What is short circuit analysis? Short circuit analysis is one of the most fundamental studies in power system engineering. It is the process of calculating current, voltage, and power levels that occur in an electrical system when a short circuit or fault happens. A short circuit is an abnormal connection of very low impedance between two points of different potential in a circuit, such as between phase to ground, two phase to ground, three phase to ground, or all three phase together. I am going to present a sample example of Fault MVA calculation to determine the fault current at particular bus bar, which will help you understand how to calculate fault current very easily. The MVA method. The MVA method is modification of ohmic method. The first step is to convert the typical single line diagram to the equivalent MVA single line diagram, and then to reduce the MVA single line diagram into a single MVA value at the point of fault. The components of a typical single line are the utility source, transformers, motors, cables, and internal generators. According to the single line diagram, the utility for MVA is 952 MVA, obtained by multiplying the square root 3 of three phase utility line to line voltage and short circuit current, which is short circuit equal root 3 V line to line I short circuit. The full MVA of 10 MVA transformer is 111 MVA because the full MVA is calculated by dividing the transformer rating by its internal impedance. Full MVA for the remaining equipment such as 6.6 kV motors, 400 voltage motors, and internal generators can be calculated in the same way as for the transformer, such as by dividing the individual equipment MVA rating by its internal impedance. When calculating fault MVA, if the system is in a series, we take the reciprocal of each value, add them together, and then invert to obtain the equal fault MVA. If the system is in parallel, we simply add the values directly. Following this step by step method, the final fault MVA at the 400 voltage pass is calculated as 28.7 MVA. In this final slide, you will see how we calculate the fault at each bus and then step by step reduce it to find the final fault MVA at the 400 volt bus. From there, we work out the positive, negative, and zero sequence MVA values to calculate the single phased earth fault. Using the basic formula, 3 times 10 MVA give us 30 MVA. Dividing that by root 3 and zero point 0.4 kilowatt give us about 43 kiloamps. So the single phase to earth fault current at 400 volt bus is around 43 kA. If you are university student, a practical electrical engineer, or simply someone fascinated by the future of electrical engineering, I hope this video gave you a real insight into short circuit analysis. If you have any questions or would like me to explain specific power system topics, drop your comments below. I will be happy to make a video on them for you. Please don't forget to subscribe my channel and share this video with your friends and colleagues. Finally, thank you for watching this video.